Good day, welcome back, and I hope that you will have fun once again working through these video lessons. And we will continue now looking at factorization of expressions. Now, remember the previous lesson we've looked at factorizing by starting with a common factor, taking out the highest common factor from the different terms in the expression. So that's always where we start. Let us continue now by looking at the second way of doing factorization. Now, first of all, before we go there, let us first look at multiplication of special binomials, and you'll see now in a moment what do we mean by a special binomial. Now, here we've got two binomials. The first one in brackets, and remember binomial is an expression with two terms. So here we've got two terms in both of these brackets. And let's look at when we multiply them, what makes them special. Here we've got, we see that the two brackets look the same, but the first one has got a plus that's separating the two terms in the binomial. And in the second binomial, we see there's a minus. So they look the same, except that the terms are separated by a plus and a minus in the two cases. So that's what makes them special. So why are they special? So let us multiply these brackets out. In other words, let's distribute the first bracket into the second one. Remember how you do that? You just multiply each term in the first bracket with both terms on the other bracket, and then you go to the second term in that the first bracket, and you also then just multiply that into the other bracket, the two terms of the other bracket. And in other words, you just distribute it in, or you expand the brackets. Let's see what we will get. So when we multiply them out, we'll get x squared minus 3x plus 3x minus 9. And you know how to get this, you just multiply that out. And then if we simplify that even further, we see that the minus 3x and the plus 3x just cancel out because they are like terms. We just add and subtract like terms to simplify, and we end up with x squared minus 9. So what does that look like? It looks like it's just the first term, or the first term in both brackets squared, in other words x squared. And then if you look at the next term that we're getting in the final answer, we see it's 9, which is actually 3 squared. And there's just a minus in between. Just hold that thought. We'll see now. Let's look at another example. Here we've got, again, it looks similar, but now we've got a plus b and a minus b. Again, two binomials that we multiply, but we just use variables so that we just see what the answer looks like. Again, let's expand the brackets. In other words, let's multiply them out, and we see that we're getting a squared minus ab plus ab minus b squared, if we just multiply each term with the other terms in the other bracket. So we see that like terms, we've got minus ab and plus ab, so they cancel out, and we end up with a squared minus b squared. Very, very interesting. So we see these special binomials, when you multiply them, in other words, two binomials that look the same, but the one has got a plus and the other one has got a minus that separate the terms. When you multiply them out, you see that the final answer, without going through all the multiplication and simplification thereafter, you can already know what the answer will be. So in this case, you see that again, like in the first place, the first problem that we've solved, we see that it's the first term in both brackets squared minus the other term squared. So what does that look like? That is what we call um, the difference between two squares. Now, let's just go through this and then just see what we have noticed. So what have we noticed? First of all, we take the second one there, the two binomials a plus b in brackets multiplied by a minus b. So we saw that the answer was a squared minus b squared. So what happened there? We see that when we expand, or when we did the distribution of the first bracket into the second bracket, what happened? We see that it looks like we just took the first term and we just squared it. And then we see that the second part of the answer is basically the second term that we just squared with a minus in between. So the final answer is what we call a difference of two squares. So this special, or these special binomials that we multiply, gives us an answer of two squares, or the difference of two squares. You see that? Very, very interesting. Now, that's when we look at when we multiply. So when we factorize a difference of two squares, it means now we will have two brackets with a plus and a minus, and then just the square root of the one and the square root of the other one in both brackets with a plus and a minus in between. We see that. So by looking at what happens when we expand the two brackets, it gives us an idea when we get the answer as the difference of two squares and we have to factorize, we know it will be two brackets, the square root of each of the two terms in the final answer, we put it in the two brackets, and a plus and a minus. Because that is what we've seen when we actually multiply. Now we know when we have a difference between, or the difference of squares rather, when we factorize them, we know how to actually factorize them. So this is the second way of factorizing. So let's continue and see how we actually do the exercises with the difference of two squares. You with me so far? Let's look at the exercise. It says factorize the following completely. And again, we must use that symbol to show exponents. And this is just an example of how we must actually use that symbol to show the exponents. Now, first of all, let's just think of the steps again. Now, we started off by saying, our first step in factorization or factorizing expressions, first look for common factors and then simplify it. And then secondly, what we've seen now, we look for difference of two squares, because we have seen now we can simplify or factorize that in a very, very simplified way. So these are the two steps up until now. First, look for common factor, first step. Second step, look for difference of two squares, and then we simplify. Let us now go to the first one here. We've got 16x squared and we've minus 25. First of all, is there a common factor between 16 and 25? No. And we only have a variable in one of the expressions. So we don't have common factors. Now we look for difference of two squares. Yes, we see here, if you look at the numbers, we see we've got 16 here and we've got 25 there. So we know immediately we can actually write these two terms. We can write it actually as 4x, that whole thing squared, because that 16x squared can be written as 4x squared, and the 25 we can write it as 5 squared. Now we see we actually got two squares and a minus in between. In other words, we've got a difference of 2 squared, or 2 squares rather. And we know now we can actually solve the difference of 2 squares. How do we do that? We know we're going to have two brackets. Remember? And we're going to have a plus and a minus in the two brackets. And how do we get the terms in the two brackets? We know it's the square root of the first term, and that we write in both these brackets, and we take the square root of the other term and we put it in the as the second term in the two brackets, and we know the one is plus and the other one is minus. So that's how we factorize the difference of the difference of 2 squared. You got that? The two brackets, the square root of the first term comes into both of the brackets as the first terms in the two brackets, and then the square root of the other term, which also now comes in the as a second term in the two brackets, and then plus and minus. So now we have our final answer. Very interesting. You got that? Let us now go to the second one. Here we've got the second one reads 25x squared minus 100y squared. So first step, we must factorize this. First step is look for common factor. We must take out the highest common factor from the numbers as well as from the variables, if there are variables that are common. So we see here, we've got 25 years numbers and 100. So we know now, yes, we have a common factor, which is 25 from the number. So we can take that out as a common factor. So what will be left when we take out the common factor? We see here from the first term, we've got x squared left. And then from the second term, we've got 25 goes into 100 4 times. And so it's 4y squared. And now we see immediately, now we have factorized it, or rather we have taken out a common factor. So the next step now is to look for, do we have a difference of two squares? Here we see we've got x squared, we've got a minus, and we've got 4y squared. So we see yes, because 2 is 2 squared and y squared we have it as a square. So we have it as a difference of 2 squares. So we can then simplify that by factorizing it using our method that we have learned of how a difference of 2 squares works, and it comes from those special binomials. So we can then solve the difference of 2 squares. So we know we've got our common factor still outside, and we're going to need 2 brackets. In other words, our 2 special binomials. And we know we take the square root of the first term and we put it in both these terms or these brackets. So we will have the square root of x squared, that's x, and the square root of 4y squared is 2 for the number, the square root of 4, and y as a square root of y squared. And then we've got the same terms in the other bracket, just with a minus. So we have simplified it, we have factorized our expression. You with me so far? You understand? Let us continue and look at the next one. This one is very, very interesting. Here we've got 4x to the power 4 minus 4. And remember, the question is asking us to simplify completely. And you'll see now why the question is actually saying that to us. So first of all, we look for, we must take out the highest common factor. We see here, we've got 4 in both terms. We can take out 4 as a common factor. And what's left in the first term, we've got x to the power 4 left. And we've got in the other term minus 1 left, because 4 goes into minus 4 minus 1. And now let's look at what we have here. We see here now we've got 4 times the bracket x to the power 4 minus 1. We know that x to the power 4 is actually x squared that is squared. You with me there? So we have x squared, which is squared to give us x to the power 4, and 1 is actually 1 to the power 2 or 1 squared. So we're having here a difference of 2 squares, which is, and we can write it then. We know that if we factorize that, we have the square root of x to the power 4 is actually x squared, and the square root of 1 is 1. So we've got x squared as the first bracket plus 1. And then the other bracket will also be x squared, but minus 1. You got that? But now what's interesting here? If we look at the other bracket, what do we have there? We have another difference between two squares. We've got x squared minus 1, and that 1 is actually 1 squared. So we can factorize that even further, because the question is we must factorize it completely. So the first part remains the same because we can't factorize that anymore. So we can solve the other difference of two squares. So we know that the first part will remain the same, the 4 in brackets x squared plus 1, that remains the same. But this difference of two squares, we can have two brackets for that. And we know square root of the first term in both of them and the square root of the second term in both of them with a plus and a minus in between for the two special binomials. Very, very interesting. You with me so far? Let us continue and look at the next one. Now here, this looks very, very interesting. So we've got here y squared minus in brackets y minus 3, and there is also squared. Now, remember up until so far, up until now, we had single variables or numbers that were squared. And out of that, we could see that we have a difference of two squares. But what's wrong with a bracket that is a squared? So when we look at these two terms here, we've got y squared, which is squared, we've got minus there, and we've got a bracket that's squared there. So we actually have a difference of two squares, although the one square is actually a bracket. But that doesn't mean it's not we can't use our techniques and skills that we've learned. So we do have a difference of two squares. Remember, we would have started with looking for of common factors, but we don't have common factors, so we can look for a difference of two squares. So we see here we do have a difference of two squares, the y squared and then the bracket y minus 3, that's also a square. So we can solve the difference of two squares. How do we do that? We've got our two brackets, and then in the first bracket we know that we've got the square root of the first term, which is y, and then we've got also the square or the square root of the second term. The square root of y minus 3 squared is just the bracket, because that's the square root. So we put in our bracket y minus 3, which is the square root of the second term. And we know that it's the same in the other bracket, it's just that we've got a plus and a minus. So what do we do now? We now simplify the brackets inside. So here we've got y plus, because we've got a plus in front of this bracket, we know it's just going to give us y minus 3. And then in the second bracket here, the smaller bracket inside, we've got y. And then we multiply minus 1 inside that bracket. We distribute the minus 1. We've got minus y, and then minus times a minus 3 will give us plus 3. And then we simplify that, and we see that in the first bracket, we've got y plus y. We've got like terms is 2y minus 3. And here also like terms, y minus y, that cancels out. And we've got 3. And we can then just rewrite it just in a much cleaner way. 3, we just write that 3 in front. So it's 3 times the bracket 2y minus 3. Very, very interesting. You got that? You with me so far? Let us continue and you look at the next one that we get here. This one is even more interesting. Here we've got 5a squared plus, or 5a squared b squared as the first term, minus 5a squared minus 5b squared plus 5. Now immediately what do we see here? We've got 5 as a common factor, because that's the first thing that we must look for. So we can take it out from all the terms, and we see now we've got 5, and then inside what are we left with? The first term we've got left there a squared b squared minus the second term a squared, and then what's left from the third term b squared, And here we've got 5 goes into 5 once, so that's 1. So that's what we have left there. Now, when we look at what we have in here, we are looking now, we have solved our highest common factor. Now we see if we can find difference of squares, of two squares. Now we can't see that immediately. But when we group the first two terms, the a squared plus the a squared b squared minus a squared, we see we can take out another common factor there, which is a squared. So let's do that. Let's leave the next part just as it is. So let's take out our highest common factor there. The 5 is still outside. Let's just change the brackets to square brackets just to make it easier. So if we take out from those two terms, we take out a squared from the first term. We see what's left there. There's b squared because the a squareds cancel out. And then the a squared goes into a squared or minus a squared once. So that's what's left there. And we have got our part that we didn't touch. Now we've got, if we look at what's in the brackets here, b squared minus 1. And we look at what's on the right hand side here, we see we've got b squared plus 1 or minus b squared and plus 1. But we know now, because they're so close to each other, if we do something to this minus b squared plus 1, we can get it the same. We can take out a minus from both these two terms and we can get it the same as b squared minus 1. Let's see how we do that. If we take out a minus, remember the first part remains the same. If we take a minus out here, we see that we will have from the minus b squared, we'll have b squared, because remember, we divide the minus 1 into the minus b squared, it's plus b squared. And the minus that you've taken out, you divide it into plus 1, you get minus 1. You got that? In brackets with our minus outside. You'll see that if you multiply the minus back in there, you'll get to the same thing, just to make sure that you've done the right thing. What do we notice now? Now we've got the bracket b squared minus 1 as a common factor, which we can take out. So we can take out b squared minus 1, and what's left here, we see that in this term here, when we take out b squared minus 1, we'll be left with a squared. And if we take out b squared minus 1 here, we will be left with minus 1 there. You with me so far? You understand? And now what do we see now? Now suddenly we've got a difference between two squares here, which is b squared minus 1. And also here we've got a squared minus 1, which is also a difference of two squares. So now we can factorize them. We know each of them will have two brackets. So we see there, difference between two squares. So we can then solve. So for the first one, remember, we've got our big brackets and our 5 outside, which was our original common factor. Now the first difference of two squares, we know we're going to have two brackets for it. And then for the next one, we're also going to have two brackets. And remember, all of them are multiplied with each other. So b squared minus 1, we know how do we factorize that. It will be b plus 1, because it's the square root of each of those two terms. The one is a plus and the one is a minus. You see that? And then the same with a squared minus 1. It will be the square root of the a squared and the square root of the 1 in both brackets, with a plus and a minus in the two brackets. Now, what's important here, we must do these things step by step, looking for common factors. If we have finished looking for common factors, we then look for a difference of two squares, and then we factorize that until we get to the final answer, because we must factorize it completely. You got that? Very, very interesting. That's it. Enjoy the exercises.